Hello everyone, I am Prashant Kumar studying at Sri Venkateswara College of Engineering, Bangalore, ISC branch, 4th SEM, USN 1VE 21IS 041, subject code 21CS42. The definition of an algorithm: a clear path to a solution, creativity within constraints, a folded masterpiece. A clear path to a solution. At its core, an algorithm is simply a set of instructions that takes in an input and produces an output, like a compass that helps you navigate through a problem space. Creativity within constraints. Despite being a rigid set of rules, implementing an algorithm often leaves ample room for creative problem solving and optimization, just like designing the perfect lighting setup. A folded masterpiece. Like origami, the process of designing algorithms is all about breaking down complex tasks into smaller and more manageable and then folding them together into a complete solution. The properties of algorithm. Firstly, efficiency. The better an algorithm is at minimizing resource usage like CPU cycles, memory, etc., the less expensive is it to run and maintain. Accuracy. An algorithm should always produce the correct output for valid inputs, just like playing a game of darts and trying to hit the bullseye. Readability. Good algorithms are easy to understand and maintained by other developers, just like developers when written literature. Performance analysis. Estimating space complexity and time complexity of algorithms. Performance analysis is essential for ensuring the efficiency of algorithms. In this presentation, we will explore how to estimate an algorithm's space and time complexities. Generally, there is always more than one way to solve a problem in computer science with different algorithms. Therefore, it is highly required to use a method to compare the solutions in order to judge which one is more optimal. The method must be independent of the machine and its configuration, one which the algorithm is running on, shows a direct correlation with number of inputs, and can distinguish two algorithms clearly without ambiguity. There are two such methods used: time complexity and space complexity. What are space and time complexities? Space complexity, the amount of memory an algorithm requires to run. Time complexity, the amount of time an algorithm takes to run. Measuring these complexities helps us understand how efficient an algorithm is and how it will perform in different situations. The importance of time and space complexity. Good algorithm design is all about balancing two priorities: the time it takes for your code to run and the amount of memory it uses. By understanding time and space complexity, you can write code that is efficient, fast, and scalable. Measuring time complexity, Big O notation. Definition: Big O notation is used to describe the upper bound of an algorithm's time taken. Example: an algorithm that takes 4n plus 2 steps has a time complexity of 0n. Importance: understanding Big O notation makes it easier to compare and contrast different algorithms. Measuring space complexity, memory usage, and Big O notation. Big O notation. Big O notation can also be used to describe the upper bound of memory an algorithm will use. Memory usage. Like time complexity, space complexity can be measured by looking at an algorithm's memory usage. Example: an algorithm that uses an array of size n has a space complexity of 0n. Examples of time and space complexities. Here, both the images differentiate between the time and space complexity. So the first example, time complexity, and the second example, space complexity. Firstly, time complexity. A brute force solver for a maze can have an exponential time complexity. Space complexity. A program that uses recursive function calls can have an exponential space complexity. Importance of understanding performance analysis. Optimizing the code, real-world applicability, problem-solving skills. The image shows the performance management of the performance analysis. Firstly, optimizing code. By understanding an algorithm's performance, we can optimize the code to be more efficient and faster. Second, real-world applicability. Performance analysis is essential in world scenarios where time and space are limited resources. Third, problem-solving skills. Performance analysis is also critical for developing problem-solving skills as it provides a framework for analyzing and optimizing the solutions. Conclusion, takeaways, and the final thoughts. By understanding the space and time complexity, it is crucial for optimizing the code. Final thoughts about the concept are: by using these concepts we have covered in the presentation, where we'll be able to analyze and optimize the algorithms like a pro. Big O notation. It is a useful tool for describing an algorithm's performance. Third point, performance analysis is important in real-world problem-solving scenarios. So this 3 point describes the takeaways which we have learned in the topic about the algorithm, time complexity and space complexity. Then the final topic, the final thoughts about this topic in the conclusion part are like: by using the concepts what and all we have covered in the presentation like space complexity and time complexity, we'll be able to analyze and optimize all the algorithms which we have covered like a pro in the future. Thank you.